We are going to combine what we have learned in heat transfer so far in terms of conduction and convection in a device called heat exchangers. Heat exchangers are devices that facilitate the exchange of heat between two fluids that are at different temperatures while keeping them from mixing together. So heat exchangers. Transfer of heat to fluids. Such devices have wide applications. Example of applications is on heating and air conditioning of household. Another one is in chemical processing. They have applications in power generation and so on. Different application of heat transfer requires different type of hardware and different configuration of heat generation or heat exchanger equipment. The simplest form of the heat exchangers are double pipe heat exchanger. So this is in terms of configuration. Double pipe heat exchangers provide a single pass, and what we have in double pipe heat exchangers is a bigger tube. They are generally made of two tubes, where inside that we have another tube. So we can have one stream of fluids getting through the inner one, let's say the hot flow in. And this is the place that's coming out. And surrounding to this smaller tube, let's say we have a cold flow. It could be the other way around. It could be cold flow in and hot flow out. So we could have cold flow in and cold flow out. Now, what you would notice here is that the inlets for the cold and hot is on one side and the outlets is on the other side. And that's what we call parallel flow double pipe heat exchanger. So this is what we call it for parallel flow. And the other one, the flow arrangements could be the opposite. Oh, this is the inner fluid that we can have, let's say, flow in, out, but the cold flow come the other way around. So this is called This is called, and that's what we call counter flow. The parallel flow, sometimes called co-current flow heat exchanger, and this one counter current flow heat exchanger. So this is the simplest one, the simplest heat exchanger that we can have in terms of double pipe. The other type of heat exchangers are cross flow heat exchangers, and they have a lot of applications. The most famous one is the one that you have seen for the car radiators, that you have the coolant that are in the type either coming downwards or from, let's say, left to right in a lot of a lot of pipe, and then we have a cross air of air just going and cooling the system. So just a schematic of that one is, let's say, we have flow, generally liquids going through the pipes. Have been arranged. So let's say this is the surface and surface for the other one. So these are the arrangement of the pipes. It could be in any directions. And let's assume we have, let's say for car radiators, we have this lens that's going in, going out from the system, like flowing inside. And then we can have another stream of fluid. So let's say this is cold stream that is just flowing, and we have exchange of the heat between the two fluids while they are not really mixed together. Now, this system, we can enhance the exchange of the heat by having fin system. So we can have like these metal surfaces that are, let's say, connecting this heat exchanger together. And like when we have this fin, it could be the flow that is flowing through the tubes could be mixed or unmixed. So let's say if we have this place that is just totally covering the surfaces, we're gonna end it up with the unmixed system here. So this is another type of heat exchanger. The other type of heat exchanger that we would see a lot in the industrial applications are shell and tube. Shell and tube heat exchanger, mainly in industrial application. So for this sort of heat exchangers, uh, what we have is we have a bigger shell. They are similar to the double pipe, but it could be like single pass like double pipe, or it could be multiple pass with the multiple type of like tubings and stuff. So an example of that would be, if I want to draw a schematic of, so let's say we have this bigger shell. And then we have this internal flow. That part. And what we are going to see here is We have arrangement of these pipes. That what we have is, let's say we have the inlet of hot stream, and they are getting in, they are going through these tubings here. So this is the tube that they are flowing in. And then we have outlet. So this is the tube inlet, tube outlet, the stream that goes to the tube. And there is the shell that these tubes are just like inserted in that. And we could have some surfaces, we call it baffle, that can promote the mixing or the movement, promote actually of the outer fluid, that created something like that. Another one here. So what happens here is, let's say the cold stream, this is the cold fluid inlet, or let's call it the shell inlet. That the flow gets in, comes here, continue the movement, and go around, continue the movement. And then we have the shell out. The fluid that is getting into shell outlet. So this is a typical of the shell and tube heat exchanger. These plates, we call them baffle, that promotes the mixing or creates turbulence in the flow that's going, and then it enhances the heat transfer coefficients, or H for the system. We can have this shell and tube with different passes. So let's say we can have, let's assume this is the shell, and the tubing inside. So tube in, tube out, and then the fluid is getting through the shell in and out. So this is one shell pass. There is one shell. And two tube passes. That's one type. We could have multiple of them. So let's say we can have this shell, and one of these baffles that's separating here the two. And we could have this tubing, So this is, let's say, for the hot stream, and then the cold stream gets in, just moves, get to the second pass, and then goes out. So this type of shell and tube exchanger, it has 2 shell passes and 4. So 1, 2, 3, 4, 4 tube passes. As you would notice, the fluid remains unmixed in the tube side. So when it's just flowing through the tube side, we have this unmixed fluid, but in the shell side, we have the mixed fluids that is just going the same thing here for the 2 passes here. And in the shell side, tube is mixed, and we have partially co-current and partially counter-current and partially cross flow that's happening. So we have both co-current, parallel flow, and counter-current flow that's happening. These are example of heat exchanger. The first one is just like shell and tube. So we have this bigger tube like the shell or double pipe, the bigger pipe, that we have the inlet for the pipe and then going out, and the smaller one that it just shows you through this application. So let's say the flow gets in and goes out. So this is a really the double pipe heat exchanger. The other one is the industrial, like you've seen a lot of chemical plants, a lot of power generation plants, and chemical processing or other scenarios. You see these big vessels that they are essentially heat exchangers. They have the shell, like this is the bigger side, and if you look at the inside shell, what you would see here is a long number of tubings that have been aligned here inside the shells, and there are these baffles that creates, like, let's say if there is a flow that is getting in, so let's say there is this flow crossing these tubes, they just go through these baffles. At the same time, these baffles are acting as a holder for the and just keeps continue as a tube. So they are just like acting as a stand too for this system. Now, baffles in general, let me just put that, call them like these are the baffles. Generally, they are increasing velocity of the shell side fluid, and we are getting either to turbulence, or by increasing of the velocity they are improved heat transfer coefficient, something that you have seen before, how we can evaluate the transfer coefficients. If we have a condensation, so let's say if there is this tube that carrying very cold fluid, and then we have a steam getting in, and we have a condensations, baffles are not necessary. The same thing for boiling. So if there is boiling happens in the system, the baffles are not really necessary.